All right, so this is a continuation of solving trig equations using a graphing approach. So as you can see here, our equation here is quite complex, meaning you have two different trig equations, trig functions, I should say, and a double angle. So a graphing approach could definitely help with that difficulty. So just keep note of the domain that we're working with. We're going from between 0 to 2 pi. So remember, that will give you an idea of what your window should be for the x values. So I'm going to use a different approach here with solving graphically. I'm going to use a method of graphing both sides, setting them equal to each other, and finding an intersection point. So I'm going to let the left-hand side equal to my y1. Right-hand side will be my y2. So let's go into the calculator and try to generate some graphs here. First of all, check if you're in the right mode. We should be in radian mode, in which we are, and then go to y equals. So remember, your y1 is going to be the left-hand side of that equation. So x minus 2 sine 2x and minus a 1. And we're going to go ahead and put the right-hand side in, which is cos x plus 2. So what we could do here to differentiate between the two graphs is I'll make the first one look a little bit thicker so you could see the difference. And let's also go to the window and arrange it a bit. So we're going from 0 to 2 pi. So my min should be 0 and my max should actually be 2 pi. So remember, your domain restriction will give you a good idea what your x min and x max should be. But y min and y max is fair game. So right now I'm actually going to leave it as negative 10 and 10. Graph it and see if we need to rearrange it some more. So here's my first graph, y1, and then here comes y2. Okay, so I already see one intersection point, which is right there, but I'm a little curious about what's happening in that region right there. So to double check if there's actually more intersection points, I'm going to arrange my range. So as you can see here, we don't need a lot of negative values. So let's go to the window here. I'm going to change my x min to about -3 and x max to 7. So once again, you just have to play with your graphs to see what window is best. So here we go. Here's the first graph, and here is the second graph. Oh, so here we go. You could see two more intersection points. We have one here, and we have two more in here. Okay, so we actually have three solutions between 0 and 2 pi. So to get the intersection point, you may have used this feature before, but we're going to use 5 for intersect. So select 5. By pressing 5, and let's say we wanted to find the first leftmost intersection point. So pick a curve or pick a point on the first curve close to that point. Second curve, you can just press enter right there. Guess, and our first x-intercept is 1.82. 1.82. So there's my first solution, but of course we have two more to find. So let's go back to second trace, select 5 for intersect, and let's address the next intersection point, which is right here. So I'm going to select a point right there, and second curve, that's fine right there, and then press guess. And my second solution is about 3.55 radians. Okay, whoops. And let's find that third last solution. So second trace again, select 5 for intersect. This time I'm not going to select any points on the left here because I might get mixed up with the other intersection points, so I'm going to go more to the right of it. So right there's fine, and then press enter again and enter one more time. And our last solution here is about x is equal to 4.21. And I believe that's it for solutions.